Okay, before we do any of this, I'm recording, okay. Let's go over the formulas you need to know. They are on the top of your worksheet. Okay, so just remember, when something is moving, up here, moving versus non-moving, which means that it's active versus stored, you got kinetic energy is the moving and the active, and the non-moving and stored is the potential energy. Now, they both have different formulas because if something's moving, you're adding in movement, which is speed or velocity, versus non-moving, you're not going to have a speed, so it's just going to be zero. And you don't want your energy to always be zero, so there's no velocity in that formula. Okay, so if something has kinetic energy and is moving, the formula is 1/2 mass velocity squared, okay? Remember, velocity is just speed, distance divided by time. So if for some reason you wouldn't get a speed or a velocity, you would have to take the distance they give you and divide it by the time, okay? Here are the units to keep in mind. Mass is always in kilograms. Velocity is always in meters per second. And then kinetic energy, after you multiply it all out, is always in joules. Now, the potential energy we're going to deal with today is gravitational. So now we have height, okay? So we have the mass in kilograms still. Gravity is a constant. We just have to memorize it or you'll always be given it, 9.8 meters per second squared. And then the height in meters. So now let's get to our problems. Okay. Let's do whiteboard. Okay. So everybody, let's do the first one. You serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand at 30 meters per second squared, or sorry, 30 meters per second. The ball has blank energy calculated. So first off, is what they're talking about something that's in motion or not? Motion, it is in motion. So which one is that? Kinetic. So in the blank, we're writing kinetic. So the first thing you always have to do is just say, is the thing I'm calculating, the thing they're talking about, moving or not moving? And then you know formula. So we write kinetic in that blank. And then right away, we know what formula to use, which is going to be kinetic energy equals 1/2 mass velocity squared. Okay. Now, let's see what they give us, okay? Underneath, anything that they give us, I'm going to sub in. So ready? You serve a volleyball with a mass of 2.1 kilograms, okay? So the mass is 2.1. The ball leaves your hand at 30 meters per second. What do you think 30 meters per second is? Velocity. The velocity? 30, but we have to square it. Okay, so now all they're asking you for is kinetic energy. So I literally, what is the decimal version of 1/2? That way we can just put it in the calculator easy. 0.5, good. So now we're just doing 0.5 times 2.1 times 30 squared, okay? You might want to do the 30 squared first, but it's, let's see, kinetic energy equals 0.5 times 2.1. 30 squared is 900, is that right? Let's put that in the calculator. Is 30 squared 900? Pretty sure. 900. Yeah. Okay, so 900 times 2.1 times 0.5 is, it should be right around 900. What is the answer? 945, perfect. 945, and what did we say that our units were? Joules. Joules. Good. Okay? Awesome. Circle your answer, that way I see it. Let's do another one. do 2. Actually, let's do one where we have to reverse it. Let's jump to 3. So they, instead of asking for the energy, they'll ask for a component of it. So let's do 3. The potential energy of an apple is 6 joules. The apple is 3 meters high. What is the mass of the apple? So first off, they already said it's potential. So this is the formula I'm going to use. Mass times gravity times height. Okay? Now, which one do we already know because it's a constant?
Gravity.
Gravity. It's always
9.8.
9.8. It's all right if you leave out the units when you're doing the math so you don't get confused, as long as you add them at the end. Okay, so ready? Now let's see what they give us. 3. The potential energy of an apple is 6 joules. Where do I put that? Which side of the equal sign? The potential energy of an apple is 6 joules.
That's not.
Good. 6. The apple is 3 meters high.
That's right.
What's our x? What is the mass? So here is our x. Okay, so first thing I would do is I would say 6 equals, what is 9.8 times 3?
29.4.
29.4? 29.4 x. Okay? Now, how do we get x by itself? Good. Divide this side by 29.4. Divide this side by 29.4. This is 1. Okay, so anything divided by itself, so this cancels out. We have x on its side by itself, and then what is that?
0.2.
0.2, and what is the mass units? Mass is always in, what is it? Kilograms, perfect. Okay. So sometimes they won't give you the energy, sometimes they'll give you the energy, and then your unknown might be the mass, so the gravity. Hardest thing you'll have to deal with is if the velocity is not there, because if it's velocity squared, y'all have to do the square root of both sides. Okay, let's finish this worksheet, and then we'll go over it hopefully by the end of the period. If not, we may just do that tomorrow since so many people are out. Okay, so work on the rest of this worksheet.
Charles Major.